Good morning. My name is Barbara Schreiner and I work for the Pegasys Institute, which is based in South Africa but working mainly in sub-Saharan Africa. We're here today to talk about how to make decisions in the face of climate change and climate uncertainty, particularly in relation to managing natural resources and making long-term decisions around such resources. What we're going to look at today is two different approaches to informing one's decisions around climate. The first is a more traditional top-down approach, and then the second is a more innovative bottom-up approach, which is particularly suitable to the African context of climate change. So the reality of climate change in Africa is that although Africa only contributes about 7% of the greenhouse gas emissions in the world, which is a relatively small amount, Africa is in fact the continent that is going to be hit hardest by climate change. And this is for two reasons. The first reason is that Africa is going to experience a greater temperature rise than the rest of the world. So where the rest of the world goes up 2 degrees, Africa, the temperature is likely to go up between 3 and 4 degrees, and that is going to have a significant impact on the continent. The second challenge is that the institutional capability in Africa for adapting to and managing climate change is considerably limited. And that means that the impact of climate change is not going to be managed as well as it is in areas that have more well-developed institutional capability. And finally, Africa in many areas already experiences significant climate variability with floods and droughts, and in many areas climate change is going to exacerbate that and increase either the frequency or intensity of both floods and droughts. And so managing climate change and making decisions now that have long-term implications is significant in Africa, and we have to be able to take into account the impacts of climate change in those decisions. As I have mentioned, there are two different approaches to looking at how to integrate climate change into decision making. The first is the more classical top-down approach. And the top-down approach essentially works from the global circulation models or the climate models of the world and says, what do those models predict about the way the climate is going to change over the next 30, 40, 50, 100 years? And having looked at that, what are the implications for the particular area where I'm trying to make a decision, whether it's a decision about the siting of a dam or agricultural expansion or energy infrastructure options? What are the implications for this area? How is rainfall going to change? What is that going to mean in terms of floods or droughts? And then from that, what does that mean in terms of the kind of decisions that we make? The bottom-up approach, which I will come to in more detail, works the other way around. It works from the particular decision that you're trying to make and the context you're trying to make, and works upwards and then tests that ultimately against the models that one has at the global level, the global circulation models. The challenge with the top-down model is that there are a number of global circulation models. The global circulation models are all based on certain assumptions, and there are slightly different assumptions in the different models. And the models come out with slightly different, or in fact considerably different, results in terms of how climate is going to change over time. And so there are uncertainties built into the global circulation models. There is no model that can give you a certain prediction of how the climate is going to change in future. So there are uncertainties in those models. When you downscale those models and try and say, so what does that mean for a particular area that are working in? Very often the uncertainties actually increase. And so one is then trying to make a decision with considerable uncertainty. And the uncertainty may even be to the extent that one model will tell you that rainfall is going to increase in a certain area, and another model will tell you that rainfall is going to decrease. And so how does one make a decision in the face of that kind of uncertainty? The bottom-up approach that I'm going to talk to you about is the climate risk-informed decision analysis developed by AGWA, otherwise known as the CRIDA approach, which looks at trying to work from the local conditions up and testing it then against the climate models. The model that I'm talking about has been based on already existing and tested models, such as the decision scaling model or the tipping point models, and it complements the World Bank decision tree, which is a essentially bottom-up approach that works at a project level. So the CREDA approach works at a scale. You can do it at a local level, at a basin scale, at a national level, depending on the scale of the decision that you need to make. And I'm now going to run through in more detail exactly how the CREDA approach works. What we have here is a diagram of the CREDA model. And as you can see, there are 7 steps in the model. And the way it has been designed is to align closely with the traditional planning cycle so that it can be integrated into a more traditional planning approach fairly simply. I will be going through each of the 7 steps in some detail, and I will also be taking you through a case study approach to give some concrete examples of how each of the steps might be applied in reality. So within this decision context, there are essentially 5 steps that one would follow. And the first of these is to understand very clearly what is the problem statement, what is the challenge that you are trying to fix, what are the objectives of the exercise that you are involved in. The second step then is to understand the performance metrics. What are the performance outcomes that you want in terms of trying to solve the problem that you have identified. The third step is then to evaluate the framework and the decision criteria for the problem that you're trying to solve. The fourth step is to understand what the key drivers or stresses are in the system that one is dealing with. And the fifth step then is to establish the requirements for the system model and actually to develop a system model. That all sounds very complex. But what in fact does that mean when one looking at it from a more practical perspective? So the case study that we're looking at is a catchment area called Farahamto. And they are trying to deal with the fact that they want to develop economically, but they are facing flood challenges. They need to manage the flood challenges in order to be able to develop economically. So adopting a bottom-up approach and looking at the decision context, in Farahamto there are a couple of issues that they need to look at. What they need to look at is what are the options that they have that will enable them to manage the flood risk. Is it the building of levees? Is it the building of a flood control dam? Is it leaving expansion room for the river to flood? What are the options that they have? And which of those, in the face of climate change, is going to enable them to manage the flood risk effectively and to enable them to develop economically? They are doing this within certain constraints. They don't have a sophisticated hydrological model of the basin, nor do they have time to develop such a model. They need to take action fairly soon. They have limited data. They have limited financial resources. And so they decide that they will work within the constraints that they have, but they need to make some decisions fairly soon. So in making these decisions and in understanding the decision context, one of the things they need to do is understand who the stakeholders are. So in Farahamto, although the issue they're dealing with is in the downstream catchment, there are stakeholders in the downstream catchment, but there are also stakeholders in the upstream catchment, because as we all know, what happens in the upstream catchment may well impact on what happens downstream. There are civil society representatives, there are business representatives, and there are government representatives. And they need to bring together these stakeholders to enable the most appropriate decision around how they're going to move forward in solving their problems. What is the objective? The objective that they are facing is to solve the flood problem in the Farahamto basin so that they can develop sustainably in the basin without the floods impacting too negatively on their economic development. So in terms of developing performance metrics, in terms of developing indicators that say this is what we consider acceptable in this region, they need to manage the flood impacts and they need to manage the economic damages caused by floods, which are going to happen, but they need to manage the economic damages. And so they need to set certain performance metrics. And they decide for themselves that they can manage one major flood in every 100 years, and they can manage a $2 million damages that they can cope with, but only if that happens within every 150 years. So that is the performance metrics that they set for their system. They say that we, as Farahamto, can cope if we only have a significant flood one in every 100 years, and if we only have economic damages more than $2 million every 150 years. Having decided on the performance metrics, they then develop a simple hydrological model based on peak flows because they only have limited resources and limited data. And having done that, they are at the end now of the decision context phase. The second step in the entire process then is to conduct what is called a stress test or a vulnerability test on the system. So essentially, conducting a stress test enables one to identify what are the vulnerabilities in the system. What are the vulnerabilities to hydrological or climate change? Where does the system start cracking if the hydrology or if the rainfall or the flood and drought regime changes? And having identified those, what are the problematic climatic conditions that result in that? So one is looking not what is changing at the climate level down, but at the system, where is the system vulnerable to climate change? And that is the significant difference between the bottom-up approach and the top-down approach. So once one has identified what the problematic scenarios are, it is critical to assess the plausibility of those problematic scenarios. There's no point in getting concerned about problematic scenarios that are really outside the bounds of probability in terms of what is likely to happen. It is at this point that it is useful to test one's scenarios against what the global circulation models are suggesting and see whether what one is looking at is within the bounds of probabilities that are coming out of the global circulation models. And so it is a testing from the bottom up against the top and not a direction from the top down towards the bottom. So in order to do this, one needs to understand how has the system performed historically? How has it performed under certain conditions? So we have a catchment, we have rainfall, we have floods, we have droughts. What has that meant in terms of flooding in the basin historically? And how is that going to change if the conditions of rainfall and the climate conditions change? The purpose of the stress test is to focus not on what is the likely climate change, but if the climate changes, what are the problematic conditions within the system? And so you try it under a number of different climatic conditions. You change the flood regime, you change the rainfall, you change the drought periods, and you test. Our system gets wobbly under these conditions, and you therefore identify what are the problematic climatic conditions for that particular system. Here we have a diagram that shows on the left-hand side what a number of the drivers are in the system, and what then some of the outputs are of those drivers. And you essentially change the drivers on the left, or the critical drivers on the left, to see what the impacts then are on the right, and to measure those against one's performance metrics. So in Faraha Mto, for example, they have said that they want to limit a particular level of flood to 1 in 100 years and the damages to 1 in 150 years. If you change these drivers, at what stage do you exceed those performance metrics? And in the Faraha Mto case, they run those changing drivers against a scenario of what happens if they put in levees, what happens if they put in a flood control dam, what happens if they leave floodplains for the flood to actually expand to, so that they can test not only the existing conditions, but some of the solutions against the changing hydrological or climatic conditions. Having done that, one then needs to understand, so how significant are the problems? If we have the problematic climatic conditions, how significant are the challenges that one's facing? If they're not too significant, okay, let's just monitor things as we go forward. If the challenges are really significant, then what are the other actions that you might need to put in place in order to address those actions? Are there further actions? So in Faraha Mto, for example, they have a look at the actions and they say, we actually need to do catchment management upstream because part of the flooding intensity is caused by denuded catchments upstream, and so we need to actually get the upper catchment improved. Perhaps we need to look at a flood control dam. So they rerun their model then, testing again, stress testing on a number of different scenarios with additional actions now added in. Then steps 3 and 4 in the model are the development of a strategy. And the development of the strategy critically requires that you have stakeholders involved, that you have the decision makers involved. So it is in fact an informed process and an engaged process with people who are in the basin and affected by the system, to then set up what are the possible alternative options and what are the various stages of actions that one is looking at, what are called pathways. Because it may be that there are certain actions that you need to implement immediately and others that follow over time, others that only kick in if the system reaches a certain tipping point. So action A may be sufficient to keep you going until the climate changes to a certain point where you need to put in action B, and one needs to work out what those pathways are. Obviously, the ultimate decisions that are made need to be made by the decision maker, and for the decision maker to be able to make effective decisions, you need a clear strategy that sets out what the problem is, what the actions are, what possible alternative actions are, what the costs are, what the time frames are, and how to go about it. So, for example, in Faraham Tor, what they then set out in their strategy is that the most immediate action is to put in place some levees to control the flooding in the short term, but that is not going to be sufficient in the longer term. In the longer term, they're actually going to need to build a flood retention dam, but that can be coming in later, can kick in year 5 in order to be in place by year 15. In the meantime, they need to actually start working with the upper catchment to ensure that there's catchment rehabilitation happening in the upper catchment. And so there are a series of actions that are marked out as a pathway to ensuring the managing of climate resilience in the basin. The fifth step is in fact developing the adaptive plan. And the adaptive plan needs to be precisely that, an adaptive plan, because we are dealing with uncertainty. There is no way that you can develop a plan now to say this is exactly where we're going over the next 30 years because we are facing such uncertainty in climate. So the plan will say this is the way we're going, but here are the points of what we need to look at to actually redesign the plan as we go along. And what is critical then is steps 6 and 7, which are implementation and monitoring. So one begins to implement the plan, but very, very critically, one has to monitor and evaluate what is going on and feed that information back into the planning process and the implementation process. So we have here a diagram that sets out how the planning, the implementation, and then the feedback of monitoring and evaluation into the process of planning and implementation. If that feedback loop of monitoring and evaluation does not happen into the planning, the replanning, and the implementation, it is not an adaptive plan. And in the face of climate change, it must be an adaptive plan. So that monitoring and evaluation and feeding it back into the process is absolutely critical. If we look at the Faraham Tor case study, we will find that in fact they haven't yet got to implementation because the decision makers are still trying to make a decision, so they haven't yet got around to the implementation or the evaluation, but we're hoping that it will happen for them soon. So in conclusion, what we have set out here is a bottom-up process of planning for climate change uncertainty, which starts with the system that one is trying to manage, looking at how that system responds to various different climate scenarios, and then looking at whether any of those climate scenarios are in fact plausible, and then working out how one addresses those vulnerabilities in a way that means that the decisions that one makes are most resilient and most robust in the face of climate change, and within a framework, above all, of adaptive planning that enables one to change the direction one is going over time. Thank you. I hope that was useful.